Dear students, a warm welcome to the physics class. Today we will discuss again the law of conservation of linear momentum. Okay, now here is the statement. If no external force is working on any system having two or more bodies, then the total linear momentum of the system remains conserved. Now we are going to prove this statement. Okay, now consider a body having mass m1 moving with initial velocity u1 and another body having mass m2 moving with initial velocity u2 on a frictionless horizontal surface. Both bodies are moving in the same direction. Okay, then the linear momentum of first body will be P1 is equal to m1 into u1. We know that the product of mass of body and velocity is the linear momentum. Okay, so P1, linear momentum of first body, P1 is equal to m1 into u1, and linear momentum of second body, P2 is equal to m2 into u2. Okay, now during collision. Now suppose these two bodies collide with each other for a small time interval delta t. Then they exert force on each other. F12 is the force on first body due to second, and F21 is the force on second body due to first body. Because of these forces, suppose the change in linear momentum of first body is delta P1 and the change in linear momentum in the second body is delta P2. Okay, now during collision, when they are interacting with each other, then at that time we can assume these two bodies as two parts of a single system. Okay, during collision, when they are interacting with each other, we can consider these two bodies as two parts of a single system where no force is acting on it. Then there is no change in the linear momentum of this system, that is delta P1 plus delta P2 is equal to 0, or we can write it delta P1 plus P2 is equal to 0. That means there is no change in the combined linear momentum of this system. That means the total linear momentum of this system remains conserved. P1 plus P2 is equal to constant. Okay, now we can write it m1 u1 plus m2 u2 is equal to constant. Okay, this is the proof of the law of conservation of linear momentum. Okay, the sum of the linear momentum, the vector sum of linear momentum remains conserved for a system. Now after collision, suppose the final velocity of the first body becomes v1 and the final velocity of the second body becomes v2. Then its linear momentum p1 dash becomes m1 v1 and the linear momentum of second body after collision becomes p2 dash is equal to m1 m2 v2 dash. Okay, m2 v2, sorry, p2 dash is equal to m2 v2. So using the law of conservation of linear momentum, the initial momentum of these two bodies is equal to the final momentum of these two bodies. That means m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we can write it minus m1 v1 plus m1 u1 is equal to minus m2 u2 plus m2 v2. Take m1 m1 term one side and m2 m2 term one side. Okay, now take m1 common. Okay, we get take minus m1 common, we get v1 minus u1 is equal to, take m2 common. Okay, take m2 common, we get v2 minus u2. Okay, m2 v2 minus m2 u2. Okay, this is the change in the linear momentum of first body and this is the change in linear momentum of second body. So we can say that the change in linear momentum of first body is equal to the change in linear momentum of second body but in opposite direction. Okay, negative sign shows that the change is in opposite direction. Okay, again the change in linear momentum of first body is equal to the change in linear momentum of second body but in opposite direction. Okay, so this is the proof of the statement of law of conservation of linear momentum. Okay, so the topic is done. Thanks for watching.